All right, I'm live in the house. Whoa, there's two of me. Okay, so I'm actually with my class today, but we're going to talk about differentiating exponentials today. So of course, we're going to start with a joke. Where do bananas learn how to split? At Sunday school. If you guys didn't hear that, the laughter in the room is just going off. Okay, so what we're going to do today is differentiating exponentials. I touched on this in the last video. Shut up, Maverick, I'm recording. So we're talking about differentiating exponentials. I touched on this in the last video, but I'm going to go a little bit more in depth because there's a couple more intricacies to it, and it might be helpful for you guys to see some examples being done. So I'm just going to go through basically the rule and then 6 different examples, okay? So the first one is, if you have an e to the x, your most basic function, if you derive it, guess what? You get e to the x, nothing changes, okay? So when you differentiate an exponential, you get an exponential, okay? It makes a lot of sense. Now, if your exponential is a little bit more fancy than e to the x, you're going to have e to the some sort of function of x. What happens is your y dash becomes the derivative of your function, that's kind of the power, and then your e to the fx remains the same, okay? So the one here on the right, that's what you get in your reference sheet. The one on the left is just kind of like common knowledge, okay? So that's what you'll be given in your reference sheet. Now, let's hit some examples. Okay, so if you want to differentiate fx equals e to the power of 4x, your f dash x simply becomes your derivative of 4x comes down to the front. So derivative of 4x is 4, and then your function stays the same, e to the 4x. So far, so good. Okay, and again, if you have something that looks a little bit more fancy, so if you've got fx equals e to the power of negative 2x plus 7, you think of that as if it was a big kind of function. What's your derivative of negative 2x plus 7? It's just going to be negative 2. So you're going to have negative 2 times e, and then back to your original function, negative 2x plus 7. Okay, now moving on, this is where it's going to start to get a little bit messier. But at this point, you're just applying the same rules of differentiation that you have always done before. If I have x and e to the x, we cannot differentiate this as is because it is a product. So I'm going to have to use the product rule. I'm going to let u equals to x, v equals e to the x. So I'm going to differentiate each one. Differentiation of x is nice, it's 1. And then differentiation of e to the x is, you guessed it, e to the x. Okay, so now to do my product rule, it means my f dash x is going to be vuv. So in other words, it's going to be 1 times x, or 1 times e to the x, which is e to the x. Product is plus, and I'm going to go my other product, which is going to be x, e to the x. Now you can factorize this if you want, but at this point it's differentiated. I'm leaving it there. Okay, now moving on to the one next to it. If you've got a fraction and there's a function on the top and a function on the bottom, guess what? We're going to use the quotient rule. So u is going to be your numerator, e to the 2x, and your v is going to equal to x plus 2. How you doing, Dylan? I'm recording a video, just saying. All right, cool. So you've got your u and you've got your v. So my u dash here, your differentiation of 2x is 2. So that comes out the front. That becomes 2e to the 2x because the rest of your function stays the same. And your v dash is a little bit nicer and simpler here. X plus 2, it's just going to be 1, right? Because you're just deriving the x. So for your quotient rule, it's going to be your vuv, but minus this time, all over v squared. So it's going to be this. Now I'm just going to keep everything in brackets to make my life easy. So x plus 2, 2e, 2x, minus e to the 2x, which is going to be that product there, all over v squared, which is just going to be x plus 2 all squared. Now, very common mistake. Do not cross out one of these for one of those because the top one is not a factor. It's just an x plus 2, so do not do that. I'm more than happy for you guys to leave it there. That is factorized. Sorry, not factorized. It is differentiated. All right, 2 more, and we're almost there. All right. Luckily for you guys, if you need to, you can go back and pause it. But if I've got some sort of product here, now I could choose to do this with product rule because I've got ex plus 1 and 2, or e to the 2x minus 2. But something that might be a little bit easier is if I expanded everything out first. Okay, so if I was to expand it out, e to the x times e to the 2x, a lot of people would say e to the 2x squared. It is e to the 3x, going back to your indice laws. e to the x plus e to the 2x, or times e to the 2x is e to the 3x, minus 2ex plus e to the 2x minus 2. That becomes your fx. Have not differentiated yet. I've just expanded the brackets. Now there's no like terms, so I'm just going to differentiate term by term. So if I'm differentiating e to the 3x, this becomes 3e3x. If I'm differentiating negative 2e x, just becomes minus 2e to the x, because e to the x derived is just e to the x. And plus 2e2x, and then that minus 2 will disappear because there's no variable of x in that question. So that there would be your derivative. And last one here, everyone's holding on tight. You guys are so quiet, great audience. For this one here, if you ever see a fraction like this, of course we could go for quotient rule, but sometimes it's easier to break it up into two separate fractions. Okay, so I could write this as e to the x on e to the negative x plus 2 over e to the negative x. Okay, now applying a little bit of, I guess, a little bit of logic here, this is the same thing as e to the x divided by e to the negative x plus, and I'm just going to write 2 to the power of negative e to the negative x. Or maybe not negative, that to the power of negative 1. Okay, so just playing around with this, this becomes x minus x, which becomes plus x. So that's e to the 2x now. And then this one here becomes plus 2e to the positive x. Okay, because it's a power of a power. I'm multiplying the powers there. And this there becomes your fx. And so your f dash x becomes a little bit easier to solve here. This just becomes 2e2x. And then plus 2ex. That there's your derivative. So it's just giving you a bunch of different options. Now you can go for quotient rule if you like, but there are going to be some instances where it's just easier to separate them and get them into simpler terms before you differentiate. All right, that's it. Hopefully that was short and sweet. I'll catch you guys later in the next video. Bye-bye.